Hello students, welcome to Toppr Study, your one-stop solution for all your JEE preparation guys. So today we are going to discuss the concept of indefinite integration, in which we are going to discuss integration by parts and integration by partial fraction method. So good afternoon everyone, good afternoon. How is everyone doing? Good afternoon guys, I hope I'm audible for you. So just give me 1 minute. I'm just looking at your chat. So guys, I'll just set up the chat for you guys. So good afternoon, everyone. Good afternoon. Good afternoon, guys. So yeah, excited for today's session. I hope everyone is excited for the today's session, guys. So as I told you, today we are going to discuss about which topic? The topic of indefinite integration, in which we are going to cover a very important topics today, a very important concepts, integration by parts and integration by partial fraction. I know many of the students have, a lot of doubts in this particular topic. So don't worry, guys. So today let us discuss those topics in a very detailed way. Okay. So good afternoon. Hi Ashish. Hello Rishi. Hi Sita. Good afternoon. Hi Thakur. Good afternoon. Hello Monster FF. Good afternoon. How are you? How is everyone doing? I hope everyone is ready. तो चलो यार शुरू करेंगे आज के सेशन. Is everyone ready, guys? Shall we start the today's session today? Okay, so let us begin the session today, guys. So hello everyone. Good afternoon. Good afternoon. So, guys, let me give you a very short intro about myself first before we start with the session. So, guys, this is Gautam, your mathematics faculty. I have done my graduation from IIT Surat. I've been teaching from past 4 years, in fact, more than 4 years now. I have taught almost 10,000 students offline and online. So, yeah, that was a very short and quick intro about myself. Okay, so let us begin the session today, and we are going to discuss today topic from this particular concept, guys, and that is related to the standard integrals of this type. Whenever you find integration of dx by under root of a square minus x square, or dx by under root of x square plus a square, or dx by under root of x square minus a square, guys, remember all those three are going to be standard integrals, for which the formulas are going to be, for this one the formula will be sine inverse x by a plus c. For this one, the formula is going to be log of x plus under root of x square plus a square plus c. And for this one, the formula is going to be log of x plus under root of x square minus a square plus c. Okay, so these are the formulas, everyone. You can actually derive it if you want to derive. No, take x equal to a sine theta in this case. Here go with x is equal to a tan theta. Here go with x is equal to a secant theta. Usually, very easily you can derive all these three formulas, guys, but try to remember the formulas, okay, rather than remembering the derivation. Yeah, derivation also, if you can remember, do remember it, but try to remember the formulas. I think that will definitely save you a lot of time in the examination. So hi Shreya, good afternoon. So chalo guys, so now let me show you the application part of this questions now. Okay, now you see the first question, everyone. You see this question. If I want to solve this integral, you can actually do it in this way. Integration dx by, you can take 49 as a common, right? If you take 49 as is common, square root of 49 is going to be 7. I'll get 1 by 7 into dx by, I'll get under root of x square plus 25 by 49, which can be written as 5 by 7 whole square. Can we do it in this way? Yes, we can do it in this way, right? Now, the second point, the second important point for you from here, guys, is that तो यहाँ से आपका अगर आप देखेंगे ये वाला एक्सप्रेशन यहाँ पे, guys, this can be written in this way. No, you see, this is exactly in the format of integration dx by under root of x square plus a square, for which the formula is going to be log of x plus under root of x square plus a square, right? So you're going to get 1 by 7 log of, okay, you're going to get x plus under root of x square plus a square. So under root of x square plus 5 by 7 whole square. This is what you're going to get, 5 by 7 whole square plus c. This is the solution you are going to get, everyone. So understood how to do this question? A very simple and an easy question. Now let me go to the second one. In the second one, you have integration of under root of x by a cube minus x cube into dx. So in this case, what we need to do, we need to find the solution of this integral. Now ये वाले question के लिए what you can do is that you can actually do it in this way. Like I tell you a very simple method for this one, guys. So what you have to do, you need to modify this into the standard form, right? So how can we do that? Very simple. What you can do is integration. You can write it in this way: integration square root in the numerator, that is x raised to 1 by 2 into dx in the numerator. In the denominator, you can write it in this way: under root of a cube can be written as a raised to 3 by 2 whole square, right? Minus x cube can be written as x raised to 3 by 2 whole square. Right, everyone? I hope you understand this. Okay. Now, from this particular integral, what you can do is you can take x raised to 3 by 2 is equal to t. If you take x raised to 3 by 2 is equal to t, if you differentiate on both the sides, what are you going to get in this case? You're going to get 3 by 2 into x raised to 1 by 2. You're going to get 3 by 2 into x raised to 1 by 2 into dx, and that is going to be equal to dt. So guys, from here, I can say x raised to 1 by 2 into dx. How much is that going to be? It is going to be 2 by 3 into dt. So let me apply this modification to this question and see what am I going to get. So I'm going to get integration, guys, x raised to 1 by 2 into dx. What is that going to be? 2 by 3 into dt whole divided by under root of a raised to 3 by 2, a raised to 3 by 2 whole square, minus of x raised to 3 by 2 is going to be t. So I'm going to get t square in this particular case. Okay. Now when you observe this integral, everyone, this integral exactly looks like this one: integration dx by under root of a square minus x square. So apply the formula. You're going to get 2 by 3 into the formula is sine inverse x by a. So t by a raised to 3 by 2 plus c. This is what you're going to get. So from this, I'm going to get 2 by 3 sine inverse of, in place of t, if you take x raised to 3 by 2, I'm going to get x by a whole raised to 3 by 2 plus c. This is the solution you are going to get in this case, everyone. So I hope the first two questions are clear for everyone. So the second question, what we have done, we have written the integral in this particular way: x raised to 1 by 2 into dx by a raised to 3 by 2 whole square minus x raised to 3 by 2 whole square square root. I've taken x raised to 3 by 2 is equal to t. After applying the substitution, you see the integral got modified into a standard form for which we have applied the formula and we got the solution directly. So I hope this question is clear for all the students, guys. Okay. So good afternoon, Preeti. Hello guys. Good afternoon. So I hope this question is clear for all the guys. So यहाँ पे these two questions are basically to show you how to apply this concepts, how to apply this formula and get the solution. So now let us understand some integrals which are going to be related to these three formulas, guys. Now, whenever you see this type of integral, no, actually in the previous class I told you, whenever you find out a integral of this type, dx by ax square plus bx plus c, in this case the method is very simple, guys. I told you, take this quadratic expression, apply the completing square method, okay, and you have to write this in either of these three forms, either this particular form or this particular form or this particular form. Right, everyone? Agreed on this particular point? Okay. Similarly, when you have square root of under root of ax square minus ax square plus bx plus c term, no guys, in this case also you have to understand that you have to be applying the same method. You take the quadratic expression, apply the completing square method. When you apply the completing square method, the denominator will be either in this particular form or this particular form or in this particular form, for which what you need to do, well, you can apply the appropriate formula and you're going to get the solution. So I hope this is clear for all the students, guys. So for example, let us see this question. You'll understand this question, everyone. So in this question, we need to evaluate integration dx by under root of 4x square minus 4x plus 2. We need to find the result of this. So how do we do this question? Very simple. So first take 4x square minus 4x plus 2. Let me apply the completing square method to this quadratic term. So what is that going to be? Well, 4x square I can write 2x whole square minus of 4x I can write it as 2 into 2x into 1 plus 2. Yes or no, everyone? So from here, you can basically write it as, well, let me write this 2 as 1 plus 1. You see, a square minus 2ab plus b square, which can be written as a minus b, 2x minus 1 whole square plus 1. So we can write it in this particular way. So therefore, instead of writing the integral in this way, we can write a dx by square root of, in place of 4x square minus 4x plus 2, you can write down 2x minus 1 whole square plus 1. So I hope this point is clear for all the students out there. Now, if you want to write this in standard form, how can we do this, everyone? Very simple. You take 2x minus 1 is equal to t. If you differentiate on both the sides, what are you going to get, guys? If you differentiate, I'll get 2 dx is equal to dt. So dx is going to be 1 by 2 integration dt by under root of, it's going to be t square plus 1. Now, when you observe this integral, after applying the substitution method, if you observe the integral which we got, well, definitely this is a standard integral of type dx by under root of x square plus a square, for which what is going to be the formula, guys? Well, the formula is 1 by 2 log of x plus, that is t plus under root of x square plus a square, t square plus 1 plus c. This is the solution you're going to get. So if you write this in terms of x, 1 by 2 log of, if you write t in terms of x, I'll get 2x minus 1 plus under root of 2x minus 1 whole square plus 1 plus c. This is the solution you are going to get in this case, everyone. Okay, so I hope this is clear for all the students, guys, and this is not for class 10th. Okay, guys, this is basically for class 11th and 12th students, not for 10th class students. Okay, so I hope this question is clear for all the students out there. So in this question, so whenever you find this type of integrals dx by square root of the quadratic term, what are you going to do? We'll take the quadratic term ax square plus bx plus c. Okay, you apply the completing square method. Okay, and you basically modify that into either of these three forms, this form or this form or this particular form, and after that you apply the formula and you're going to get the solution. So I hope this question is clear for all the students. So now let me go to another type of integral which is going to be related to those three formulas which we have discussed. Okay, and this is going to be that type of integral. So guys, in this case, what you need to do is, whatever method we have applied, if you recall, whatever method we have applied for linear by quadratic, the same method you need to apply in this case. So you have this linear term, no, px plus q. You write it as m times of the differentiation of the quadratic term, which is 2ax plus b plus n. By comparison, you find the values of m and n, and from that you're going to get the solution. Simple. Okay, so for example, you see this question. From this question, the things will be clear for you. So guys, everyone, again, you see here you have a linear term in the numerator and a quadratic term inside the square root in the denominator. So in this case, what method you need to apply? Let us do it in this way. 2 minus 3x is going to be m times of the differentiation of the denominator, which is going to be 2x minus 6, okay, plus n. This is what you are going to get, everyone. Now let me find the values of m and n. How do we do that? Well, by comparison you can do that. So 2 minus 3x is equal to, so 2mx आपको मिलेगा minus of 6m plus n. If you compare the coefficients of x on both the sides, I'll get 2m is equal to minus 3. So from here, the value of m is going to be minus 3 by 2. And also guys, minus 6m plus n value is going to be how much? If you equate the constants, it is going to be 2, right? So if you put m is equal to minus 3 by 2, What is the value of n I'm going to get here? Let us look at that. So for m is equal to minus 3 by 2, let us see what is the value of n you're going to get. So 2 ones are, 2 threes are. So guys, it's going to give you n plus 9, okay, is equal to 2. So the value of n which you're going to get in this case is minus 7. I hope this point is clear for all the students. Okay, so from here, therefore, I can write down 2 minus 3x as m, which is going to be minus 3 by 2 into 2x minus of 6, okay, minus of 6 plus n, which is going to be minus 7. So this is what you are going to get. Okay, so therefore, what you're going to do right now is that in place of this integral 2 minus 3x by under root of x square minus 6x plus 25 into dx. In this particular case, in place of 2 minus 3x, you take the right hand side expression, and that is minus 3 by 2 into integration 2x minus 6 into dx whole divided by under root of x square minus of 6x, right? X square minus of 6x plus 25, x square minus of 6x plus 25, okay, and minus of 7 integration 7 into dx by under root of it's going to be x square minus 6x plus 25. This is what you are going to get, everyone. Okay, so I hope this is clear for all the students. Now what are you going to do? How do you solve this particular integrals? You see, both the integrals are going to be standard integrals, guys. यार कैसे करेंगे यार? Simple सा logic है. The first one यहाँ पे, if you take x square minus 6x plus 25 is equal to t. If you differentiate on both the sides, I'm going to get 2x minus 6 into dx is equal to dt. So by this modification, what is going to happen is that ये जो भी इंटीग्रल है ना यहाँ पे, this is going to get modified into this particular form, integration dt by root t form, and that is the standard integral for which you already know how to find the solution, right? And if you see the second integral, this is basically of this type, integration dx by under root of ax square plus bx plus c. And you already know, we already have discussed in today's session only how to deal with this type of integrals. So apply the method and you are going to get the solution. So I hope this is clear for all the students. Good afternoon, Yesh. Very good afternoon. So this is how you have to solve this type of questions, everyone. So whenever you find this type of questions, what you have to do, write linear as differentiation, m times of differentiation of the denominator, the quadratic term, plus n, and find the values of m and n by comparing the coefficients of x and constants on both the sides. And after that, in place of 2 minus 3x, you take the right hand side term. Okay, so in that way, you're going to get these two integrals, and these two integrals will be standard integrals, guys. The first one, just by taking the quadratic term is equal to t, the numerator will become dt. So it is going to be in the form of dt by root t, which is a standard form for which we can apply the formula and get the solution. The second one is a very simple one. In the second one, I told you it's going to be of this type. So you already know the method how to deal with this type of integrals. So I hope this is clear for all the students. So now let me go to another important concept, and that is going to be related to integration by parts, everyone. Now in the case of integration by parts, you need to understand this very important thing, guys. When should we apply the concept of integration by parts? Okay, so whenever you want to integrate the product of functions, let us say, for example, let us say you have integration of x into sin x into dx, and you need to integrate this one. So in such type of questions, when there are going to be product of two functions, you can definitely apply the concept of integration by parts, everyone. Okay, so how do we apply the concept of integration by parts? Well, first let me explain you the formula. The formula of integration by parts is integration u into v is given by u into integration v minus whole integral u dash into v. इसका जो भी result मिलेगा, you have to integrate it once again, u dash into going to be whole integral u dash into integration v. So whatever result you're going to get, u dash into integration v, it's basically you have to integrate the result once again with respect to x. So guys, this will be the formula of which one? The formula of integration by parts. Okay, so this is going to be the formula of integration by parts. So I hope this is clear for all the students. So now the important thing which you have to understand is, how do you know which function is u and which function is v? Yes or no? You have to have this idea, right? You see in the integral above, x into sine x into dx. How do you know exactly which one is going to be u and which one is going to be v? Well, for that we have a very simple rule, and which is going to be the integration by parts. May we have a very simple rule, and which is going to be the elate rule. So what is this elate rule going to be? Let me explain that to you in detail. So ILATE. You see this word elate. Okay. So guys, in elate, each and every letter is having a special meaning. It's going to indicate a unique function, guys. Okay. So for example, let us say the letter I is going to indicate the inverse trigonometric function. What is the letter I indicating? Inverse trigonometric function. The letter L is simply going to indicate the logarithmic function, guys. And the letter A is simply going to indicate the algebraic function. The letter T is going to indicate the trigonometric function. And finally, the letter E is going to indicate the exponential function. So everyone understand this, that the letters in the word elate, each and every letter is going to indicate a unique function. Okay, so in this order, in this particular order, whichever function you're going to get first, that is taken as u, and the later function is taken as v. For example, you see in the question, guys, in the question of integration x into sine x, where x is going to be the algebraic function, sine is going to be trigonometric function. So in this order, you see which one is going to come first? The algebraic one. A is coming first, right? So x is going to be taken as u, because here a, which is going to be an algebraic function, it is going to be first in that order. So x is going to be taken as u, and the later one is of course going to become v. So in this way, you can decide which one is going to be the function u, which one is going to be the function v, depending upon the order of this elate. Okay, so now once you got to know which one is u and which one is going to be v, all you have to do is apply the concept, the formula of integration by parts. So according to this formula, the formula is going to give you the result, which is going to be u into, that is x into, integration sine x into dx minus whole integral differentiation of u, differentiation of x is going to be 1, इंटीग्रेशन sin x into dx, and इसका जो भी result मिलेगा, you have to again integrate it with respect to x. Okay, so here guys, sin x integration is minus cos x, so I'll get minus of x into cos x, and again integration sin x is going to be minus of cos x. You already have a negative sign here, so negative of negative positive, integration cos x into dx, and from here I'm going to get minus of x into cos x, and integration cos x is going to be sin x plus c. This is the solution you are going to get in this particular case, everyone. So this is how you need to apply the concept of integration by parts. So in the case of integration by parts, first thing you need to understand, integration by parts is going to be applicable wherever you have the product of two or more functions, and if you want to integrate it, in that case you can apply the method of integration by parts. And in case of integration by parts, according to the formula, you need to decide which one is u, which one is going to be v, and for that we have the rule which is called as elate rule. And in case of elate rule, where this word is containing the letters I, L, A, T and E, and all these letters are basically indicating unique functions like I inverse trigonometric, L logarithmic, and so on. Okay, so I hope this entire method is clear for everyone. Now let me do one thing. Let me do a question. In fact, let me discuss a special concept which is going to be related to the integration by parts, everyone. And that is going to be this particular concept. Okay, so guys, in this concept, you need to understand whenever you find integrals of this particular type, integration e raised to x into f of x plus f dash of x into dx, whatever result you are going to get, the result is directly e raised to x into f of x plus c. So a simple example to make you understand this, integration, you have e raised to x into sin x plus cos x plus c. Okay, sin x plus cos x into dx, everyone. Now here you need not to apply the integration formula, integration by parts formula. You can directly get the solution. How can we get the solution? Very simple. You see, f of x, if you take it as, sin x, if you take it as f of x, then can we say cos x is going to be, can we say this cos x right here is simply f dash of x. So whatever integral we have here is simply going to be of this particular type, e raised to x into f of x plus f dash of x. And what is the result going to be, guys? Well, the result is going to be, the result for that type of integrals is going to be e raised to x into f of x. So basically, this is what you're going to get, e raised to x into sin x plus c. This is the solution for this integral, everyone. So that's what I'm telling you. Whenever you have integrals of this particular type, no, you can directly apply the solution in this way using this result. You can directly get the answer for this type of integrals, everyone. So for example, let me show you a question for you. आप लोग ये वाले question देखो. Evaluate integration log x by 1 plus log x whole square into dx. We need to find the solution in this particular case. So how do we do this question, everyone? Any idea? Anyone is having any idea how to do this question? Like, just think about the methods, the different methods which we can apply to solve this question, everyone. Good afternoon, Yuvaraju. Good afternoon. Hello, Geeta sir. ये कौन सा class चल रहा है यहाँ पे? This class is of indefinite integration, and specifically today we are talking about integration by parts and also the partial fraction method. Okay, so anyway, let us get back to the session. So in this question, guys, what we can do is we can take log x base e is equal to t. Right, everyone, we can take log x base e is equal to t. So what is x going to become? Well, x is going to be e raised to t. Okay, now when you differentiate on both the sides, when you find dx, you'll get e raised to t into dt. Let me apply this modification to the above question and see what are you going to get, everyone. So log x is going to be t, okay, dx is going to be e raised to t into dt whole divided by 1 plus, guys, log x here is going to be t, so 1 plus t whole square. This is what you're going to get, 1 plus t whole square, everyone. Okay, now you need to understand one very important thing. यहाँ पे अगर आप देखेंगे I is equal to integration e raised to t into dt, okay, into यहाँ पे you have t by 1 plus t whole square. Okay, so what I'm basically doing here is I'm adding and subtracting 1. So let me add and subtract 1 here, t plus 1 minus 1 divided by t plus 1 whole square. Let me do it in this way. Now from here आप देखेंगे यहाँ पे I is equal to integration, I'm going to get e raised to t into, you see, let me take t plus 1 separately. I end up getting 1 by t plus 1 plus minus 1 by t plus 1 whole square. This is what you are going to get, everyone. If you do the simplification, this is what you are going to get. Okay, now try to understand. If you observe this integral now, guys, yeah, this is going to be f of t. If you take 1 by t plus 1 as f of t, if you differentiate 1 by t plus 1, definitely this is going to be your f dash of t, right? So don't you think this integral यहाँ पे is exactly in this format? Integration e raised to x into f of x plus f dash of x into dx. Don't you think this integral is exactly in this particular format, for which the solution will be directly e raised to x into f of x plus c. So if you apply the solution in that way, guys, what is the answer you're going to get? You're going to get e raised to t into f of t, that is 1 by t plus 1 plus c. This is the solution you're going to get. So I is going to be e raised to t is x divided by 1 plus, well, t is going to be log x. So x divided by 1 plus log x plus c is going to be the solution in this particular question, everyone. So I hope this question is clear for all the students out there. Okay, so in this question, what we have done, first we have modified the question into this particular form. In fact, this particular form. And from here, what I have done is that I try to convert this question, modify the question into this particular form. So I got it. And directly using the result of this, we got the solution. So in this way, you can use this particular formula, guys. This is very important in examination, JEE examination, there were a good number of questions based upon this particular formula. So this question and this method, I hope it's clear for you. So now let me go to another integral, which is going to be related to which one? Related to which one? Related to the integration by parts. That is going to be this type of integrals. If you find integral of this type or this type, you can directly use the formula, guys, which is going to be e raised to ax by a square plus b square into a sine bx minus b cos bx. And if it is cos bx, you can write down e raised to ax by a square plus b square into a cos bx plus b sine bx. For example, you see this question, everyone. We need to evaluate integration e raised to 2x into cos 3x into dx. Okay, so यहाँ पे यार a is equal to 2 and b is going to be 3. So therefore integration e raised to 2x into cos 3x into dx, according to the formula, it will be e raised to ax, e raised to 2x by a square plus b square. So 9 plus 4, it is going to be 13 into a cos bx. So 2 cos 3x plus b sin bx. So plus 3 sin 3x plus c. This is the solution you are going to get, everyone. आप देख सकते हैं, देखो a cos bx, so a value is 2, so 2 cos 3x, and then b sin bx, so 3 sin 3x. This is the solution you're going to get. So directly you can apply the formula and get the solution, guys. And remember one very important thing, that if you don't remember the formula, let us say in the examination, let us say you completely forgot the formula of this two integrals, guys. In that case also, you can solve the question. All you have to do is apply the integration by parts concept. Okay, what you'll do here, apply the concept of integration by parts. You can do it in this way. According to the Elate rule, okay, we can say this exponential function will be v, the trigonometric function is going to be u. So apply the integration by parts and you are going to get the solution. Okay, so I hope this is clear for all the students, guys. Anyone is having any more doubt, you can you let me know in the chat box. I'll definitely help you out, guys. But this is how you have to apply the concept, apply the formula and get the solution. So I hope this is clear for you. Now let me go to another standard integral which is related to the concept of integration by parts, and that is these three formulas right here. Guys, all these three formulas are going to be derived using the concept of integration by parts only. I'll not do the derivation part for you right now, okay? But these are the formulas which are going to be important. So the first one, under root of a square minus x square. Second one, under root of x square minus a square. The third one, under root of x square plus a square. So the integrals of these three are going to be in this particular way. And let me tell you a very simple way to remember these three formulas. I mean, I do that way. I remember these three formulas. It might look very lengthy, but I remember these three formulas in a very simple way. You can also use the same method. Ab dekho yaar, in each and every formula, in each of these three formulas, the first term is always x by 2 into the question itself, right? You see, x by 2 into this particular term, x by 2 into this particular term, x by 2 into this particular term. So this thing is sorted out that for these three formulas, the first three is always going to be, the first term is always going to be x by 2 into the question. In question, whatever expression you have, you can directly take that expression. Okay. Then you have to take positive sign or negative sign. How do you decide it? Very simple. Just look at the sign of a square. If the sign of a square is positive, you take the positive sign. If the sign of a square is negative, you go with the negative sign. So see here, a square is positive. So I have taken positive sign here. A square is negative. So negative sign here. A square is having a positive sign. So again a positive sign here. Okay. And then you take a square by 2 in each and every term. A square by 2 is common. So a square by 2, a square by 2, a square by 2. Now along with the a square by 2, which term are you going to multiply? Very simple. If you take this in denominator, this question, that particular expression in the denominator, what formula you're going to get, just take that formula, just take the result of that formula and multiply that with a square by 2. That's it. You see, if you take a under root of a square minus x square in the denominator, which is going to look something like this, dx by under root of a square minus x square, for which we do know the result. It is going to be what? Well, it is going to be sine inverse x by a plus c, right everyone? So directly take this result, multiply karo a square by 2 say, you're going to get the final formula. The same thing do with this one as well as this one. So in this way, guys, you can remember these three formulas very easily. So what you're going to do here, the first term is always x by 2 into whatever expression you have in the question, that you take it. Okay, then whatever sign you have to take, positive, yeah, negative, just look at the sign of a square, take that particular sign, and the next term is going to be a square by 2, and along with a square by 2, what term you have to multiply? It is going to be the result which you're going to get if you take this in the denominator. If you take this term in the denominator and integrate, जो भी result आपको मिलेगा, just take that result and multiply with a square by 2. So I hope this is clear for all the students. So for example, you see this question, everyone. So in this question, what we can do is, I'll take 4 as a common. So I can write this as 2 into integration under root of 9 by 4 minus x square into dx, which can also be written as 2 into integration under root of 3 by 2 whole square minus x square into dx. So this looks like which formula? The first one, integration under root of a square minus x square, right? So directly apply the formula in this particular case, everyone. So what is the result you're going to get? You're going to get 2 into x by 2. So x by 2 into under root of this term, which is going to be 3 by 2 whole square minus x square plus a square by 2, that is 3 by 2 whole square by 2 into sine inverse x by a. So sine inverse x divided by a, and yahan pe plus c. This is the solution you are going to get in this case. So I hope this is clear for everyone. Anyone is having any doubt in this particular case, students? I hope this question is clear for all the guys here. So again, I'm telling you, whenever you find this type of integrals, just modify it and write it in the standard form, then apply the formula. From that, you are going to get the solution. So I hope this question is clear for all the students out there. Now let me go to another type of integral, in which if you find this type of integral, no guys, and let me tell you, this integral is going to be related to these three formulas. Okay, now when you find this type of integrals, no, the method is quite simple. Yeah, I told you already, whenever you find the quadratic term, no, in the denominator or inside the square root, अगर आपको quadratic term दिखेगा, just apply the completing square method, everyone. So in this case also, you'll be doing the same thing. For ax square plus bx plus c, you apply the completing square method and see which form you're going to get. Are you going to get this particular form, or this particular form, or this particular form? Well, according to that, you have to apply the formula and get the solution. So for example, you see this question, everyone. Well, in this question, evaluate integration under root of 2x square plus 3x plus 4 is given. So what you'll do first, you'll take the quadratic term, 2x square plus 3x plus 4. Well, let me write this. Let me apply the completing square method first to this one. So guys, क्या मिलेगा आपको? 2 into x square plus 3 by 2 into x plus 2. This is what you're going to get. So this can be written in this way. No, 2 into x square. Guys, let me multiply and divide by 2. So I'll get 2 into 3 by 4 into x plus 2. This is what you are going to get. So from here, I'm going to get 2 into x square plus 2 into 3 by 4 into x plus, guys, let me add and subtract 3 by 4 whole square, which is 9 by 16 minus 9 by 16 plus 2. Okay, so this is what you are going to get. तो अगर आप देखेंगे ना यहाँ पे 2 into this is a square plus 2ab plus b square, which is a plus b whole square, x plus 3 by 4 whole square minus 16 twos are 32. 32 minus 9 is going to be 23. So plus 23 by 16. This is what you're going to get. So therefore, instead of writing the integral in this way, we can write it in this way. Integration root 2 into square root of, I can write it as x plus 3 by 4 whole square. This root 23 by 4 whole square into dx. Root 23 by 4 whole square into dx. Now you see this integral, everyone. So what we can do, you can take x plus 3 by 4 is equal to t. So dx is going to be dt. Okay. So if you apply this modification, everyone, to the integral, you're going to get root 2 into under root of t square plus root 23 by 4 whole square into dt. This is what you are going to get, everyone. If you observe, guys, अगर आप observe करेंगे ये वाले integral को, यार, this is going to be in the standard form. It's going to be in under root of x square plus a square form. So apply the formula. From that, you are going to get the solution. So this is exactly in this format, no? Under root of x square plus a square into dx के format में है. So apply the formula and you are going to get the answer. So I hope this question is clear for all the students, guys. Anyone is having any doubt? Sir, आप क्या पढ़ा रहे हो यहाँ पे? Guys, I'm basically teaching you the concept of indefinite integration, in which we are discussing about indefinite integration by parts and also the integration by partial fraction. So this is going to be related to integration by parts wala concept. Okay, and after this we'll start with the integration by partial fraction also. Okay, so I hope this question is clear. So whenever you find any integral in which you have square root of quadratic term, what you need to do in that case, quadratic term ko you have to first apply the completing square method, write it in any of these three forms, this one or this one, and then you have to apply the appropriate formula and you're going to get the solution. Okay, so now let me go to another question. You see this question, everyone. Now ये वाले question में you see linear into under root of quadratic. So when you find linear into under root of quadratic, no, यहाँ पे भी the same technique. You remember linear by quadratic, linear by square root of quadratic. Like let me write down linear by quadratic में, नहीं तो यार linear by square root of quadratic में, whatever technique you have applied, whatever method you have applied, you need to apply the same method, that is px plus q is equal to m times of differentiation of this quadratic term plus n. Find the values of m and n. After finding m and n, what you will do, in place of px plus q, you write the right hand side term and then you can do the simplification. So I hope this is clear for all the students, guys. So this is how you have to do the integrals, the questions of this particular type. Okay. Now, एक काम करेंगे. Let me do a previous year question for you guys, dependent on the concept of integration by parts. Okay. So guys, everyone, look at the question given for you. तो यार ये वाले question में this is given for you that if f of x, I mean, if integration x raised to 5 into e raised to minus 4x cube into dx is given for you, and if that is equal to minus 1 by 48 into e raised to minus 4x cube into f of x plus c, where c is going to be the constant of integration. Then the question is here, f of x nikalo. What is f of x going to be in this particular case? So let me tell you, ये वाला question कैसे करेंगे? Simple सा method है. Guys, let me take this term, which is going to be, let me take I is equal to integration x raised to 5 e raised to minus 4x cube into dx everyone. Okay, now you need to understand that यहाँ पे let us apply the concept of integration by parts. Okay, so what is integration by parts? How do we apply that? Very simple. First, let me write this as x square into x cube into e raised to minus 4x cube into dx everyone. Okay, and after that what you can do is you can take x cube is equal to t, and if you differentiate on both the sides, guys, what am I going to get? I'll get 3x square into dx, and that is going to become dt. Or we can write down x square into dx is going to be dt by 3. Right, everyone? So let me apply this modification in the question and see what am I going to get. So I'll get I is equal to x square into dx will be 1 by 3 integration dt into e raised to minus of 4t into dt. This is what you are going to get, everyone. Okay, so I hope this is clear for all the students. Already मैंने यहाँ पे dt लिख दिया. So 1 by 3 dt into e raised to minus 4t, and ये x cube के place में it is going to be t. So this is what you are going to get. Right, I hope this is clear for you. Now what you have to do, let me apply integration by parts to this integral now. So according to the rule elate, exponential यार v होगा, t is going to be u. So let us apply the integration by parts and see what am I going to get. I'll get I as 1 by 3 integration. So it's going to be 1 by 3 into. So guys, I'm going to get t into integration e raised to minus 4t is e raised to minus 4t divided by minus 4 minus of whole integral. Differentiation of t is going to be 1, and integration of e raised to minus 4t will be e raised to minus 4t divided by minus 4. So I'll get plus 1 by 4 into dt. So this is what you are going to get, everyone. From here, let us see what is the solution. I'm going to get 1 by 3. This is minus 1 by 4 into e raised to minus 4t into t. Okay, and what is this one going to be? Minus of 1 by, if you integrate e raised to minus 4t once again, I'll get minus 1 by 16 into e raised to minus 4t plus c. This is what you're going to get, everyone. Now let me do one thing. Let me take the LCM यहाँ पे. In fact, e raised to minus 4t and minus is common. So minus of e raised to minus 4t, I can take it as a common, divided by 3 into, if you take the LCM as 16, I'll get 4 into t plus 1, 4 into t plus 1 plus c. This is what you're going to get, everyone. So from here, let me write it in this way. I is equal to, let me take t is equal to x cube. I'll get minus of e raised to minus 4x cube divided by 16 threes are 48 into 4 into, again t के place में you can take x cube. So 4x cube plus 1 plus c. This is the solution you are going to get, everyone. अगर आप compare करेंगे, if you compare the result we got to the result given in the question, guys, what is f of x going to be? Well, f of x is going to be 4x cube plus 1. And if you see the options, everyone, actually options में यार थोड़ा सा typing mistake हो गया. This should be plus 4x cube plus 1. So the option is going to be D. The correct answer in this question is going to be option D. So I hope this question is clear for all the students out there. So basically ये वाले question में what we have done, very simple. First यहाँ पे हमने integration by substitution method we have applied, okay, and after that the question got modified into this particular way, in this particular in this particular way the question got modified. We got this particular integral. Now to this integral we have applied the integration by parts method, and from that we got the solution. So I hope this question is clear for you. So guys, this question is a previous year question asked in JEE Main 2019. It was a previous, मतलब easy question था, not a very difficult question. If you are familiar with the concept of integration by parts, then you could have easily done this question, guys. Okay, so I hope this question is clear for all the students. So now let me start discussing the concept of which one, the final concept of today's session, and that is related to partial fraction method. Now, what is this partial fraction method going to be? Well, let me explain to you in a very detailed way. So guys, यहाँ पे देखो, partial fraction method में basically what are you going to do? Remember this very important point that partial fraction method is only going to be applicable for proper rational functions. Now you might be having this doubt, sir, what is proper rational functions going to be? Guys, very simple. Let me write it down for you. If you have any function of this type, f of x by g of x, okay, where g of x should not be 0, where g of x should not be 0, okay, if you have any function of the type f of x by g of x, where f of x and g of x are going to be polynomials, and g of x is not equal to 0, then those are called as rational functions. Okay, हमने डिस्कस किया था rational functions के बारे में in a very detailed way in the standard functions and their graphs in that particular chapter, in that particular class, everyone. Anyway, now यहाँ पे, now in the rational functions you have two types of rational functions depending upon the degree of numerator and denominator. If the degree, let me write it down for you, if the degree of the denominator is greater than the degree of numerator, the degree of denominator is always going to be greater than the degree of numerator. Guys, in that case, do remember whatever you're going to get, whatever, what I can say, whatever function, or let us say whatever rational function you're going to get, it is known as proper rational function. What is that function going to be? It is known as proper rational function. Okay, and if I say degree of the numerator, if it is going to be greater than or equal to degree of the denominator, let me write it down for you. Degree of, agar degree of numerator, if the degree of the numerator, if it is greater than or equal to the degree of the denominator, in that particular case, what is going to happen? Well, you are going to get an improper rational function. You're basically going to get what? An improper rational function. Now, you need to understand one important thing, guys, is that partial fraction method is only going to be applicable for proper rational functions, not for improper rational functions. So what happens if an improper rational function is given for you? Let us say integration of, you have this type of question like x cube plus x plus 1 divided by x square plus 2. Okay, I'm taking a random question, guys. So if you have this type of improper rational function, no, guys, always remember this very important point. Let me write it as a note. You can always write an improper fraction. You can also call it as improper fraction, guys. Okay, improper rational function, improper rational function as an algebraic sum of polynomial and a proper rational function. An algebraic sum of polynomial and a proper rational function. Well, how do we do that? Very simple. All you have to do is apply the long division method. सबको पता है यहाँ पे long division method क्या होगा? We have done that in our class 10, right? So applying the long division method, improper rational function can be written as a combination, as an algebraic sum of polynomial and a proper rational function. From that, you can basically write improper in terms of proper, and then you can apply the concept of partial fraction. So I hope these basics are clear for you. Now let us actually dive into the main concept of partial fraction method, guys. So basically partial fraction method का मतलब क्या होगा कि whenever you have a proper rational function, and if you are resolving that into simple proper rational functions, then that method of resolving them into simple proper rational functions are simply nothing but the partial fraction method. For example, you can see here, this is going to be a proper rational function. This one is also a proper rational function. This one is also a proper rational function. Now, अगर आप ये example observe करेंगे, when you're resolving this, when you're writing this in this particular way, well, you're basically resolving this particular proper rational function into simple proper rational functions like this. So this method is simply nothing but the partial fraction method. You're basically resolving them into partial fractions like this. Okay. So इससे advantage क्या होगा sir? What is the advantage? Like, you know, like this is fine. This is completely fine. But इससे advantage क्या होगा? What advantage are we getting by applying this method? Well, think in this way. If I'm asking you, integrate this particular function. So you can do that. It's not that you can't integrate the left hand side. You can do that. You can apply the concept when you have linear by quadratic. You have this case like linear is equal to m times of differentiation of quadratic plus n. We do have that method. Or else what you can do is if you want to integrate the left hand side, instead of integrating the left hand side term, you integrate the right hand side integrals. I mean this particular terms everyone, which are very easy. You see, right hand side integrals are very easy. You can easily get the result. So if I ask you, compare karo, are you going to apply that linear by quadratic wala method, or are you going to partial fraction? Are you going to apply the partial fraction method and integrate the simple terms? Well, definitely this method is easy, no? क्योंकि यहाँ पे the integration part is going to become very easy for you, right? So this is the advantage everyone. So whenever you're basically applying the partial fraction method, you're basically resolving the given proper rational function into a much more simple proper rational functions, and integrating them is going to become very easy for you, and that will save you a lot of time. So this is going to be the importance, guys, you know, the main concept of partial fraction method. Now in the case of partial fraction, we have three types. I'll discuss one by one very quickly. The first type for you is when you have non-repeated linear factors. So वहाँ पे how you have to do the partial fraction, how you have to resolve into partial fractions, very simple. You can see this example everyone. You see g of x is having all the non-repeated linear factors. So in this case, what you can do, you can basically write it in this way. You can write it as a1 by x minus a1 plus a2 by x minus a2 plus a3 by x minus a3 plus so on, an by x minus an. So you can definitely write it in this particular way. I hope it's clear for you. So for example, let us say this question is given for you and you have to solve it. Okay, you have to find the value of this integral. So you can do it in this way. You can take x plus 2 by x plus 3 into x plus 1. Okay, so applying the partial fraction method, you can write it in this way. आप कैसे लिख सकते हैं यहाँ पे? You can write a by, so these two are non-repeated linear factors. So you can write it as a by x plus 3 plus b by x plus 1. Okay, now all we need to do is find the values of a and b. So how do we find the values of a and b, everyone? Very simple. Just take the LCM. You're going to get x plus 2 is equal to a into x plus 1 plus b into x plus 3, right everyone? And the denominator terms are anyway going to get cancelled. So from here, we need to figure out the values of a and b. To find the values of a and b, I'll tell you a very simple method. Just take the values of x in such a way that one unknown value will get eliminated and the other unknown value ka answer you can easily find out it directly. So for example, you see here, if I put x is equal to minus 1, you see what is happening. A will get directly eliminated and you'll get the value of b as 1 minus 1 plus 2 is 1 divided by 2. Similarly, if you take x equal to minus 3, what is going to happen? B will get eliminated and you'll get the value of a as a into minus 2 is equal to minus 1. So a is going to be 1 by 2. So from here, we can definitely conclude that whatever you're going to get, so you can write down x plus 2 by x plus 3 into x plus 1 in this particular way, which is going to be a by, which is 1 by 2 into 1 by x plus 3 plus b by, what is b going to be? 1 by 2 into 1 by x plus 1, you can definitely write it in this way. Yes or no? तो यहाँ से advantage क्या होगा? Instead of integrating the left hand side term, what are you going to do? You are going to integrate this right hand side terms, everyone. So right hand side terms are very simple. क्या होगा? Integration 1 by 2, integration dx by x plus 3 is going to be a log of x plus 3 plus 1 by 2. Dx by x plus 1 is going to give you log of x plus 1 plus c. This is going to be the solution. So I hope this is clear for everyone, guys. This question is clear for all the students. So whenever you want to apply the partial fraction method where the denominator is containing non-repeated linear factor, what you'll do in that case, take one non-repeated linear factor along with a constant like a, b, c in the numerator and write it in this way. And from that, you just have to figure out what is the value of a and b. And from that, what you'll do, instead of integrating the left hand side, integrate the right hand side, you are going to get the solution. So I hope this question is clear for all the students. Now let me go to a second type in which there are going to be repeated linear factors. So guys, यहाँ पे आप क्या करेंगे? What happens? What are you going to do when you have repeated linear factors, everyone? Well, let us say that you have this type of, this type of expression, guys. Let us say x plus 2 by, let us say x plus 1 into x minus 3 whole cube. In this case, if you want to apply the partial fraction method, no, observe this method, everyone. First, for the non-repeated linear factor, you take it as a by x plus 1. For the repeated linear factor, it is repeating 3 times. तो यहाँ पे आपको क्या करना पड़ेगा? You need to write 3 terms, and the 3 terms are going to be in this way. You need to first take b by x minus 3, then c by, you increase the power by 1 now, which is x minus 3 whole square. Now d by, again increase the power by 1. So that is going to be x minus 3 whole cube. And in this way, you need to apply the partial fraction method for the repeated linear factors. How many times it is repeating? That many terms you have to write, in which for each and every term keep on increasing the power in the denominator by 1. So for example, you see this question, x square plus 1 by x minus 1 whole square into x plus 1. I need to solve this integral. So यहाँ पे आप क्या कर सकते हैं? You can definitely apply the partial fraction method. So according to the partial fraction method, what you can do? You can write it in this way, no? X square plus 1 by x plus 1 into x minus 1 whole square. So according to the partial fraction method, if you see the denominator, non-repeated linear factor is there. Repeated linear factor is also there. So how do you do the partial fraction? Very simple. First, a by, you'll write the non-repeated linear factor, x plus 1. X minus 1 whole square is there. It is repeating 2 times x minus 1. So you can take b by x minus 1 plus c by x minus 1 whole square. So in this way, you can do the partial fraction and then taking the LCM, finding the values of a, b, c, and then instead of integrating the left hand side, you are simply going to integrate the right hand side. So I hope this question is clear for you guys. The rest of the part I'm giving you as a homework. Definitely try kar lena, okay? But this is how you have to do the partial fraction. Okay, now let me go to this next part, the next type of partial fraction, in which if it is going to contain irreducible quadratic factor. What do you mean by irreducible quadratic factor? Very simple. For a quadratic term, ax square plus bx plus c, if the discriminant value is less than 0, in that case we call it as irreducible quadratic factor. मतलब ये जो भी quadratic factor है ना, you can't further reduce it into two linear factors. It's always going to be that thing, because यहाँ पे no real roots are going to occur for that quadratic factor, because discriminant is less than 0 for that. So for that type of terms in the denominator, how do we apply the partial fraction method? Very simple, guys. You take a linear term of this type for a quadratic factor which is going to be irreducible. So for example, you see this question, आपको ये वाले question से idea मिलेगा partial fraction कैसे करना है. So guys, in this question it is given 3x minus 2 by x plus 1 into x square plus 4. So what you can do in this question is, first x plus 1 is given. It's a non-repeated linear factor. So you can write that as a by x plus 1 plus, now x square plus 4 is given. It's a non-reducible, or I can say irreducible quadratic factor. So for this, how should you write the partial fraction, everyone? Well, you write the irreducible quadratic factor in the denominator. You write a corresponding linear term, which is going to be like this, bx plus c in the numerator. So this is how you have to do the partial fraction when an irreducible quadratic factor is involved. So यार ये quadratic factor के लिए always remember, in the numerator take a linear term of this type, ax plus b, bx plus c. It should be like this one, constant into x plus another constant. It should be of this particular type. Okay, and after doing that आप क्या करेंगे, LCM ले लो, find the values of ABC, and after that, instead of integrating this term on the left hand side, you integrate these two terms on the right hand side. You are going to get the solution. So I hope this question is also clear for you. I mean, the rest of the part, finding the values of ABC and integrating these two terms, I think you guys can do it also. It's very simple. So I hope this is clear for you. So guys, these are going to be the three types of partial fraction method. So first type, non-repeated linear factor. This is how you have to do it. This is how you have to resolve it into the partial fractions. And then you have the repeated linear factor, and this is how you have to resolve it. And whenever you have irreducible quadratic factor, this is how you have to resolve it into partial fractions. So I hope this is clear for you. And guys, with that, we are to the end of this particular session today. So guys, today we have discussed the integration by parts topic, and also the concept of integration by partial fraction, and also one special integral at the starting of the session. We also have done some good number of questions and also a previous year question from integration by parts topic. So I hope you have understood all the topics which we have discussed today, guys. And with that, guys, take care everyone. And if anyone is still not a part of this awesome Telegram channel, guys, yeah, join kar lena. Okay, you can join that through this particular link, or you have the QR code here. Directly scan karo. By scanning, you can directly join the Telegram group where you get all the instant updates and exam related notifications in that particular group, everyone. And one more important thing, very important thing. I know many of the students are watching the sessions, they are enjoying the sessions. But guys, you're not liking the video. And yes, matlab, again, you are enjoying the sessions, right? You're understanding everything. So like to banta hai na? So guys, do like the video, do like the sessions, everyone, so that these videos are going to be recommended to many number of students like you, and all those students are going to get benefited. Okay, and अगर आपने subscribe नहीं किया, subscribe कर लेना, and stay tuned to the channel for such awesome videos, and share these videos to your friends so that they can also learn all these topics like you guys. Okay, so chalo guys, with that, thank you so much everyone. Take care guys. We'll meet in the next session, that is going to be at 6 p.m. And at 6 p.m. we are going to discuss the miscellaneous integrals topic. Okay, there are some integrals which are going to be important for your JEE main examination. So I discuss those integrals, those type of integrals in the 6 p.m. session, everyone. So with that, thank you so much everyone. Take care guys. Bye everyone. Meet you at 6 p.m. today with another interesting topic of indefinite